Okay, we're back and solving equations again in 6.1 and 6.2. Last video we did equations with variables on both sides. We've got them again on both sides, but now there's decimals involved too. So let's see how we can do these types of questions. I'm going to show you two ways of doing it without the algebra tiles, because it's kind of hard to draw 0.002 of an algebra tile. But one way is to just keep everything with decimals and use those algebra properties we've done before. And method number 2 says, hey, I don't like decimals, so let me see if I can rewrite the question without decimals, and then only use, I guess, whole numbers or integers to help solve the equation. So I'll show you both, and then I'll let you once again decide what you like better. Okay, here's example number 1. Scary equation here. But let's just keep the decimals. So, by keeping the decimals, I'm going to ask you, do you want to have the variables x on the left side or the right hand side? So that's the first thing you need to choose. I'm thinking the decimal on the left hand side is smaller, and so having a smaller decimal means it's probably best to get rid of that one so that our answer remains positive. So I'm going to actually subtract 0.002x on both sides. Don't be afraid to use your calculator if you don't like these decimals. That means that now, on my left-hand side, I'm still going to have 0.05. 0.03 minus 0.002 is, I believe, 0.028x minus 0.006. So that's what we have so far. Okay, notice we've now isolated x on one side of the equal sign. I guess I have to move the decimal 0.006 to the right-hand side. So 0.056 equals 0.028 times x. And then once again, just like before, I have something times x. The opposite now is to divide by 0.028. And you can do that on your calculator if you wish. I'm going to do it in my head. I'm going to say x equals 2. I think 56 divided by 28 is just 2. Okay? Keeping decimals. Same properties before. No biggie. But if you hate decimals, then let me just quickly show you what you could do. Let me just over here on the side give you this question first. If I give you something like this, 0.3, or not maybe that. Let me just give you this. How about just 3x equals to 6? When we're solving that, of course, x equals to 2. What happens if I were to now multiply each of the terms of 3x equals 6 by 10? Well, 3x times 10 is 30x, right? And 6 times 10 is 60. Now I have this equation, 30x equals to 60. And if I solve this one, 60 divided by 30, that's equal to 2. So notice what happened. I multiplied every single term by 10, but my answer still didn't change. My equation changed, right, but my final answer did not. And that's the idea here around how to remove the decimals. Notice that we've got decimals in the hundredth place, in the thousands place. So I'm going to ask you to multiply by some factor of 10, whether it be 10, 100, 1,000, 10,000, and whatnot, to get rid of the decimal. In this case, because we have thousands places, I'm going to say let's multiply everything by 1,000. So times by 1,000. So what I mean by that is take that 0.02x, and I want you to times that by 1,000. Okay? Times that by 1,000. Now you take the 0.05 times that by 1,000. Take the 0.03x, guess what? Times that by 1,000. And take the 0.006, and yes, guess what? Times that by 1,000. So everything, and this is the key, everything has to be multiplied by that same power of 10. 1,000 times 0.002x is just 2x. 1,000 times 0.05, that's just 50. 1,000 times 0.003, that's 30. And that, I believe, is just minus 6. So notice now we have an equation that no longer has decimals. Woohoo! So go ahead now and try to solve. So this is just like before when we did the previous lesson. I'm going to subtract 2x off of both sides. I'll get 50 on the right, and I get 28x now on, 50 on the left, and 28x on the right, minus 6. I'm going to add 6 to both sides. 56 equals 28x. And then we'll solve for x by dividing by 28, so x equals to 2. Same answer. Yay! I don't know which one you like, but for those of you who hate decimals, probably method 2 is the one for you. Okay? Going to do the same thing for question B. Alright. And let's see what we can do here. Funny thing now is we've got brackets. Keep the decimal. Sure, let's do that method first. So we'll keep 0.09x. With brackets we have to distribute, so 0.13x plus 1.3 equals to 20. Notice now we have x's on the left-hand side, which is great, but we have to combine like terms. So I'll combine them together to give you 0.22x plus 1.3 equals to 20. So that's like terms, just combining. Now I'll ask you to subtract 1.3 on both sides because I want to isolate the x. So 0.22x equals to now 20 take away 1.3, that's 18.7. And then go ahead, do some division here. That's kind of scary, so I'm going to bring out my calculator. Woo! 18.7 divided by 0.22. Oh, it's not bad. 85. So I forgot to just tell you what I was doing there. Divide both sides by 0.22. 85 is my answer. Okay? Once again, you can always plug it back in to check, but I'm going to say it's right. Let's do this one more time by removing the decimal. So in this case, notice my decimals are in the 100th place, and that's the only one I want, or I have. So I'm going to suggest we multiply by, 100. So remember, we're taking every single piece. So let me just write this down here. Times that by 100. Okay? Going to take this 0.13. Now notice, I know there's a bracket here, but we're just multiplying this whole thing by 100. Okay? And then we got the 20, and we're going to multiply that by, of course, the 100. Okay? So 100 times 0.09x is just 9x. That's cool. Here's the interesting part. Do I actually take the 100 and distribute that into both of those? And the answer is no. The reason is the 0.13 is multiplied by this expansion of x plus 10. It's like me saying 2 times 3 times 4. Do I go 2 times 3 and then 2 times 4? Think about that. 2 times 3 is 6 times 4 is 24. If I were to distribute the 2, 2 times 3 is 6, 2 times 4 is 8, 6 times 8 is 48. I've got an extra factor of 2. No good. So in this case, that 100 only applies to the number outside of the bracket. So 100 times 0.13 is 13. Leave the bracket alone. Don't multiply that by also 100. 20 times 100, I think, is just 2,000. And there you have it. A nice equation with whole numbers or integers. And now we can just expand and simplify. So there's 9x still. 13 times x is 13x. 13 times 10 is 130, equal to 2,000. 9 plus 13, I think, is just 22. Now we're just trying to collect like terms, right? So 22x plus 130 equals to 2,000. I'm going to subtract 130 off of both sides. 22x equals to 1870, I believe. Last step is to just divide by 22, and let's hope it's the same answer. Is it the same answer? Yeah, 85. So once again, I want you to think about which way works for you. Okay, I would like you to know both ways, but I know you probably have a preference. Okay, turn the page. 2 more questions, okay, and then we're done for this lesson. Once again, think this is the same thing as really before, so I don't really have anything I need to say to you that's new. So why don't you try this one on your own, and then come back and double check your answer with me. And this one asks you to do both methods. Example number 4 actually only asks you to do one way, so you choose whichever one you wish. Maybe I should just make this change. I think let's make both the variables the same, so let's make it a little m, and then you should be able to solve. So guess what? This page is on your own. So you try it first, then come back and double check your answers with mine. Alright, pause the video. select like term. Isolate the variable. Solve for y. Removing the decimal, I see a 0.3, which is 3/10, a 0.35, which is 35 hundredths, multiplied by the largest, that would be 100. So that becomes 30y. There's only these two get multiplied together, so 35. Gonna keep distributing. Gonna collect like terms. Isolate the variable. Divide by the coefficient, and voila, y equal to 30. I bet that those of you like getting rid of this. So I'm going to do that. I'm getting rid of the decimal. 1.2 or 1 2/10, 2.5 or 2 5/10. Hence, we need to multiply by 10. Multiply by 10, multiply by 10, multiply by 10. Once again, only the outside number. Don't do it to the inside too. Now I'll expand. 12 times 7.5. I think that's 90. You can double check. Oops. Subtract 12 divide those guys by 15 and equals to 20.